see what happens in a typical DevOps process, that you kind of, see in your organizations as well as, while dealing with your deliveries, right? I'm going to introduce two typical roles here that you would see. One is your developer, who basically using the command line or whatever developer tool has created a container, right, or updated a code and checked it into a Git repository. And then the Git repository has a webhook that triggered Jenkins, and which internally they triggered a Docker in terms of composing a container, deploying it to the registry, and probably to the cloud as well at the same time. And once it's done, there is a DevOps guy who comes in and also deployed it to the production or one of the environments, to the target environments to which you wanted to deploy. And maybe there is a version 1 and he's upgraded it to a version 2, right? So you have a developer, you have a DevOps guy who updated an image and who has deployed an image to a target environment. Now there's a third guy who comes in, the operations guy, who wants to keep an eye and make sure that these lights are on and the production is actually running in. He has certain runbooks that the developer team or somebody would have already given them, from which he knows what to do when something goes wrong, and based on which, if he's signed up seeing there is a high load or the capacity is going beyond what the current capacity of the production is, he would try to just add and deploy these new service to that. Now, there are 3 different roles that we have talked about here, right? One is the developer, the other is the DevOps guy who's developing it, and the operations guy who's trying to just keep the lights on for the infrastructure and the environment itself. Now, once you deploy this container or a code, there are a ton of things that you need to keep an eye on or monitor on and manage on, right? Some of the things are the infrastructure or the application starts sending you alerts, right? There's a business data that is coming up, and there is an operational data that's coming up. So that somebody needs to just curate all this data and load somewhere so that they can kind of use it for their future decisions that you want to make, or if you want to make any changes to it, right? At the same time, the SRE teams should constantly make sure that they're enforcing policies, they're managing the services, they're managing the containers and the infrastructure at the same time, right? Now, there is a whole set of processes that are tasks that are involved for SRE folks to kind of to manage this application that is deployed. While the SRE folks are trying to just do that, right, troubleshoot, optimize based on the alerts and the business data, the operational data that they have received, there is continuous application development that the developer is doing, because he's agnostic to now the infrastructures that you have. He's basically pushing the code into the repository, and the code gets deployed in the DevOps world, right, and to the environment. Now, when that's for one cloud, and it seems to be relatively simpler, right? The way there is a data coming in, that the SRE teams are trying to fix the issues, keep the things on and going and keep the ball rolling, right? But then what happens in the case where a specific application is kind of diversified into multiple clouds, or and also including your data center, right? Enterprises today have, and that's what if you look at the trend or the numbers that some of the numbers that Siba and Amit has shown, they're saying there is a lot of inclination to deploy on multiple clouds and multiple clusters, and there are good reasons we have actually seen before in our previous slide why there is a tendency to just, right? And this could be the complexity, if you have that in this case. There are multiple clusters giving you alerts, giving you, business information, all of that needs to be managed at the same time, right? And it basically makes the SRE or the managed services teams and the DevOps teams, people, trying to stay, latest on this, with this kind of, alerts, stuff like coming in, it kind of becomes a nightmare for these teams to manage such situations, right? That's where you would want to have a solution that can keep track of all these services, talk to these services, monitor these services, and kind of manage this communication between these services, right? And store some telemetry about these services to a centralized database. Some of those requirements that Amit was talking about in his challenges that he has listed, right? He wanted a centralized place where he can monitor logs, traces, etc., 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 right? And he also wanted a place where you can have a single dashboard that you could just look into all of this. That's where Istio comes in, right? Istio is a language-independent way of automate application network functions, right? I'll back up with this, with an example that I have. Say there are two services, say for example, that are running on your infrastructure. One is the front end, and there is a payments process that actually the customer can come buy something and do the payment process and get it shipped, right? It's a typical e-commerce in a small scale that I've represented here, right? Istio, to start with, comes in as a packaged thing with the Kubernetes, meaning which every new release of Kubernetes has an equal upgrade of Istio that comes along. And hence when you install a managed engine, you have Istio also available as a part of it, right? All you have to do is enable it, so that. Now, to start with, what Istio does is kind of auto-discovers all the services in your multiple clusters, environments, on-prem, etc., right? That's what it does. It basically auto-discovers all the services running across your, not only limiting to one cloud, but multiple clouds. If you have your applications deployed, and also, including your on-prem, right? Now, once it does that, it basically installs a network proxy right inside the pod, very close to the service itself, so that it can monitor the inbound and outbound traffic of it, right? And that's where most of your information starts coming into and flowing in into your central database, where you can start monitoring of your services, right? So at the core of it, Istio automatically deploys a mesh of proxy servers along your application, giving uniform observability into your workload at a service level, and allows make smart decisions, routing traffic, enforcing security and encryption policies, right? So there are a ton of things that this Istio does. Let's see how does it do that, right? So if you look at, or if you're familiar with Istio as the control plane, there are three major things, right? The first one is called the pilot. The pilot, what it does basically is it talks to all the proxies and deploys configuration and routing rules. Say you have, once the Istio is enabled on your proxy, the pilot basically talks to all these proxies that are enabled on each of your services and basically deploys configuration and routing rules, meaning, right? And the mixer comes in along and enforces these policies and tells you what service can talk to what, right? Not every service can talk to every other service, right? Front end might not want to, this is the payments may not want to talk to another that's irrelevant in this context here. It basically, ignores that, and says, hey, these are the services that can talk to each other. These are the services that cannot talk to each other, right? The another cool thing that, Mixer does is the telemetry. Once you have started capturing the inbound and the outbound traffic of each of your service, it starts writing that all the data of logs, traces, analytics, information into a central database, right? The central database is called StackDriver. We will talk about in detail later, right? Citadel comes in to enforce your security and encryption policies on it, right? So, hey, this service has, if you have to, contact this service, this is the encryption that you need to use. This is the security you need to have in place, and distribute security certificates to all these proxies so that they have the right certificate to kind of unlock a specific service for them to communicate, right? So there are multiple users. This is a very, very important, component of Anthos again. And this plays a very, very important role in terms of managing all your data information, etc. for all your clusters, right? Now, we spoke about Kubernetes, how it basically manages your clusters. We spoke about Istio, how it manages your communication, security, enforce policies, and etc., etc., between your services. right? And now the Anthos seems to have, is already giving a lot of flexibility in the way, it manages, we can manage clusters and, stuff like that. But then when you give so much flexibility, we tend to do kind of compromise on certain things, right? We might to take a shortcuts in terms of, enforcing policies and probably do something to get our job done, right? Not necessarily it is in line with the policies that are defined for the whole infrastructure as a thing, right? Now that's where Anthos configuration management comes in, right? It is the one that basically ensures that all your clusters are kind of managed with a common set of policies, right? And the policies could be anything, right? Security at a scale, right? They're all managed and enforced at a scale. You cannot have diversified policies or different policies for different clusters unless you intend to. But then, as a thing, if you want to maintain consistency and homogeneity across your clusters, the important thing is to have somebody govern that policies, and drive them to be consistent across your clusters, right? If you're familiar with Kubernetes, you might have heard something called infrastructure as a code. The way Anthos operates is similar. It basically applies policies as a code, right? So you have a set of policies that you want to build in like an YAML file or something, check it into your Git repository, deploy them, and make sure that you have homogeneity across all your platforms and clusters in the platform, right? It also gives you the ability to pre-commit validation. Say, hey, you wanted this code your policy to be spread, distributed across or enforced across all of these clusters. Yes, no, kind of a validations. These are some of those cool things that GitHub in conjunction with configuration management tool presents you, right? All right. So moving on, the next important thing is the Knative, which we talked about as one of those key tools of Anthos platform itself, right? Now, so the Cloud Run is a managed version of Knative. If you're familiar with, Knative was a collection of a set of developer tools, right, that Google provides you to kind of build up and deploy applications into GCP, right? The managed version or the hosted version of Knative is Cloud Run. The reason Cloud Run has come in is because, if you remember, we were talking about serverless architecture, serverless as an infrastructure, right? And people started asking about how Kubernetes can basically manage serverless architectures as well, right? And the answer for it is the Cloud Run, right? Cloud Run is the one of the popular ways of deploying, running containers, right? Agnostic, to the infrastructure. You don't have to worry about infrastructure at all. All you have to write is a piece of code and register it on Cloud Run, right? The only caveat here is there needs to be stateless. The containers have to basically manage everything as a functionality as its own, right? And once you deploy this, it gives you a secure URL that you can map to your domain, right? And you need to also provide a port number on which, as an environment variable on which you want this container to be run, etc., right? So since you are only giving the code and the Cloud Run is doing the serverless execution or implementation of your code, it also automatically scales up and scale down as and when it is required. And the important thing is you would only pay for the cycles or the compute that you have used based on the implementation or the busyness of your application, right? And one of the key aspects is there is a component called Cloud Run for Anthos. This is specific for certain high intensity computations that you want to perform. Say, for example, you have a big data lake on which you're building a lot of analytics, which involves a lot of intensive compute that it takes care of. Or if you're building machine learning routines or running machine learning routines on top of a data for your application, you might need bigger, than something that are CPUs, and you can ask that specific, piece of codes to run on high configuration hardware such as GPUs and TPUs. GCP provides instances that are backed up by GPU and TPUs, but you can, even if you have specific hardware that you already purchased and invested in your on-prem data center, you can hack Cloud Run to basically deploy that code on that specific piece of hardware, right? So, which is essentially pushing back to the point that I still want to use get the benefit out of my existing hardware, right? And if you have already invested on it, I don't want to lose that value there, right? So Google claims out of all those inventions or the research at the technology revolutions that they did, Cloud Run is one of the outstanding, a technology component that stood out for them, and in the way they basically look at deploying code and managing code, seamlessly in a serverless mode, right? There are the other few components of Anthos. We talked about telemetry that Istio collects from each service. Once as it start communicating with the network proxy inside a pod, right? It gathers all the logs, traces, alerts, etc., into a central database wherein you can monitor all of them at one point. StackDriver also have this cool ability to integrate with your code, wherein you can put specific checkpoints on your code, and if something goes wrong, you can debug that code, and it takes a snapshot, and saves it to your database for so that you can handle that incident at a later stage, right? The one thing that I like about StackDriver is the way it extends beyond monitoring, the services that are deployed into GCP and enabled by GCP by StackDriver. It basically goes beyond, and if you have specific applications and services that are running on an Amazon cloud or an Azure cloud, it still extends its capabilities and fetches all the data from that cloud as well, right? So this is very close to me, the StackDriver, because my world where I do a lot of performance optimization and tuning, a lot of historical data of application, a lot of historical data of the services is paramount to me, so that I can kind of understand better the user behaviors, the workloads, and the way the users are approaching or interfacing with their applications, right? And if I want to get ready my loads for the future, I would have a good history of information that StackDriver collects and gathers and puts it in a central database that I can just read into and kind of make my future workload designs and etc. So this is something that I constantly use. This has cool interfaces that are the APIs that it exposes to some of the analytical tools or monitoring the interface, the front-end tools that interfaces with, such as Prometheus, Datadog, etc., into which this information can be fed, and I can carve out specific business technology or user-specific dashboards out of it. Right? This is a cool tool. Keep an eye on it. This is going to be very, very handy when you have implementations that are deployed on cloud. The last important configuration or the component of the Anthos is the marketplace. Marketplace is that thing wherein you want a third-party software, not necessarily a software that you have developed on your own, to act and to work with in conjunction to your existing infrastructure, right? A lot of software providers have worked with Anthos to provide interfaces, default templates, and settings that they could basically deploy a specific software at a click of a button into your infrastructure and use that seamlessly, right? if you say, for example, I want to monitor my build analytics of all the stack data that StackDriver is accumulating, and I want to make sense out of it and build cool analytics out of it, I might want Splunk to work in conjunction to my infrastructure, to my applications. I can just simply have Splunk deployed at a click of a button. And the cool thing about it is any of these third-party softwares that you kind of invoke and start using it, they come with default templates. You might want to customize it, but then most of the default templates work out of the box. And then once you do it, they seamlessly work with your applications and do the specific functionality or the responsibility that these softwares have to perform, right? Another cool thing is any third-party software that you kind of invoke doesn't have to be necessarily built separately. Google has a tie-up with all these people, so they kind of, all this cost that is involved in basically using or consuming a third-party software is all built in comes in as one single GCP bill, right? Right, so there you are. I have sort of gone through almost every core component of the Anthos. We discussed about Google GKE, the Google Kubernetes engine that's running on GCP. On the right, in the blue box, we have a GKE running on-prem. We discussed Istio as your service mesh, doing the communication between your services, gathering telemetry, enforcing policies, security, etc., etc. Configuration management tool that comes in as a thing that kind of comes in to manage consistency and homogeneity across your workloads. It could be your tool and your tool configurations or your environment configurations or your, right, etc. They're all stored at single place, deployed and maintained, consistently across. And we also spoke about a centralized UI on the left side of you, and there's a gray box where it comes in with a single dashboard, etc., giving you one clean picture of all your clusters, no matter where they are located, right? They all come into, there is a specific column on the dashboard that gives you, hey, this cluster is out of San Francisco, this cluster is out of New York, this cluster is out of Bangalore, Delhi, etc. So all your clusters are actually consolidated, aggregated into one single plane, right? And then we spoke about StackDriver, your one centralized place where your information all gets gathered. So further, you can use it for your various debugging, troubleshooting, incident management, etc. kind of aspects of your application management and operations management as well. We spoke in brief about marketplace that falls in middle. You can have marketplace, deploy softwares to both your on-prem as well as the GCP side of things. And this whole interconnect, an outbound connection, TLS connect that basically connects both of your worlds of on-prem and cloud, that makes it, right? So once you do that, I would like to leave you with this, a comprehensive view of Anthos, right? Imagine your world to be like this in future, wherein your applications won't run of your own data center or a cloud or a specific cloud or a single cloud. They would be more than likely than you imagine. They would be distributed across clusters, multiple clouds, etc. And when you have such scenarios, Anthos can come very, very handy in managing, comprehensively, from a single pane, all your, infrastructure assets. Right?
Can we take questions now?
Yes. So I think I'm done with this. If you want to get started with Anthos, come join me, be a part of my research. For starters, you could just go to these links I've mentioned here, and then, we can take it out from there. Welcome to the world of Anthos. Thank you. All right. Thank you so much, Siba. You kind of made a closing statement as well. Thank you so much for that. But so thank you guys. I can't thank you more for kind of spending 2 hours of your weekend time. Hope this session has been interesting. Sort of worked as a refresher for you in these boring COVID times that we spend a lot of time at home. We would try to just follow up this session with a few more in future that we would want to make it even more interesting with kind of talking about some of our implementations of in this space. We might probably bring you some of demonstrations of what we did on our in our Google Anthos labs within Sapient. All that we want to show you in future as well. So please stay tuned. You guys stay safe and be safe. Thank you.
All right. Thank you.
Thank you all. Bye.